The article discusses a study that provides the first evidence of a necessary violation of symmetry at the moment of creation, which could explain why there is more matter than antimatter in the universe. The study was conducted by University of Florida astronomers, who studied 1,000,000 trillion three-dimensional galactic quadruplets in the universe. They discovered that the universe, at one point, preferred one set of shapes over their mirror images. This idea, known as parity symmetry violation, points to an infinitesimal period in our universe's history when the laws of physics were different than they are today, with enormous consequences for how the universe evolved. The finding, established with a high level of statistical confidence, has two primary consequences. First, this parity violation could only have imprinted itself on the future galaxies during a period of extreme inflation, in the earliest moments of the universe, confirming a central component of the Big Bang theory of the origin of the cosmos. Parity violation would also help answer perhaps the most crucial question in cosmology. Why is there something instead of nothing? That's because parity violation is required to explain why there is more matter than antimatter, an essential condition for galaxies, stars, planets, and life to form in the way they have. The researchers defined right and left-handed galactic tetrahedrons, based on how galaxies were connected to their closest and farthest partners in these imaginary shapes. Their method required analyzing 1 trillion imaginary tetrahedrons for each of 1,000,000 galaxies, a mind-boggling number of combinations. So they developed sophisticated mathematical formulas that allowed the immense calculations to be performed in a reasonable period. The technical aspects of the analysis make it difficult to say whether the universe prefers right-handed or left-handed shapes, but the scientists saw clear evidence that the cosmos does have a preference. They established their finding with a degree of certainty known as 7 sigma, a measure of how unlikely it is to achieve the result based on chance alone. Although the scientists are confident in this signal of parity violation, it remains possible that uncertainty in the underlying measurements could explain the asymmetry. Thankfully, much larger samples of galaxies from next-generation telescopes could provide enough data to erase these uncertainties in just a few years. The findings by the researchers can't yet explain how we ended up with this crucial abundance of matter. The how will require new physics going beyond the standard model, which explains our current universe. But the new results do strongly suggest that there was an asymmetry at the earliest moments of the Big Bang. Now the race is on for scientists to produce a theory that can explain the mirror image preference of the universe and the excess of matter.